This year in AI robotics felt like the birth of a whole new era. Unitree's G1 shocked everyone again, this time sinking basketball shots with human-level control over a ball that shouldn't even be predictable. And Xpeng finally dropped the price of their hyper-realistic female iron robot, sending another wave through the industry. But hold on. Figure 02 stepped away from BMW's assembly line bearing the wear and tear of 11 months of real deployment, proving that humanoids can survive true factory conditions. And over in China, 6-month-old startup MindOn stunned everyone with a home robot moving so smoothly that people genuinely forgot it wasn't human. Even Sunday Robotics joined the moment, revealing Memo, a home robot built for real life instead of flashy sci-fi stunts. Welcome back to AI Nexus, and today, AI robots are becoming way too real. These are the most shocking AI robotics updates of 2025. Up until now, the G1's world was clean and controlled. Every demo had one variable, the robot itself. Balance, speed, coordination, all inside its own system. But the moment you introduce a bouncing basketball, everything becomes chaotic. Now the robot has to predict motion, control pressure, stabilize its body, and time its release, all while tracking a moving object in real time. And somehow, it works. We've all seen the G1 do wild things before, but basketball forces the robot to learn a completely new skill set. It has to grip the ball without crushing it. It has to aim based on the hoop's exact location, not just an estimate. It has to calculate gravity, distance, and release timing in one smooth motion. And while doing that, it's constantly adjusting its stance based on what the cameras see, frame by frame. Here's what makes this so insane. All of this is happening at the exact same moment. No pauses, no hesitation, no processing moment, just a continuous stream of vision, motion planning, torque control, and balance working together at full speed. But the detail that shocked everyone is this. The G1 isn't just taking random shots. It's mimicking actual NBA signature moves. LeBron's single-leg silencer pose, Kobe's fadeaway jumper with the backward lean, mid-range footwork that takes humans years to master. These moves require rock-solid balance on one foot, perfect upper body and lower body timing, a controlled release angle, and extremely fast reaction to micro-adjustments. Humans build this through muscle memory. The G1 learned it with data and did it in months. Let me know in the comments. Is this real progress for humanoids or just a flashy demo to go viral? Now let's talk about how the G1 actually learns this stuff, because this is the part most people missed. Unitree is using a new system called ASAP, a framework that teaches the robot sports skills by aligning simulation with real-world physics. It looks simple on paper, but it's incredibly powerful. Stage 1. Training in simulation. First, Unitree records real basketball movements from human players. Jump timing, foot placement, body rotation, shot release angles. Then they convert all that motion into a data format the robot can understand. Inside simulation, the G1 can practice thousands of attempts without breaking hardware. It can fail fast, correct its posture, test different release timings, try different grip pressures. Every successful shot and every bad shot becomes part of the G1's training library. Stage 2. Training in the real world. Once the robot understands the theory, it tries the moves in real physical space, and at first, it fails constantly. Too much force on the ball, not enough rotation, incorrect weight shift, leaning too far back, releasing too early. But every failure creates new data that tells the system where the simulation and the real world don't match. Slowly, those two worlds begin to align. And with each iteration, the G1 gets smoother, faster, and more accurate. One of the hardest challenges is the grip. The robot's hands have to automatically adjust how tightly they hold the ball. Too much pressure and the ball warps or slips. Too little and the ball shoots out of its hands like a rocket. So the G1 is making tiny corrections the entire time, tightening, loosening, stabilizing, all in sync with the rest of the shot mechanics. Now let's break down the 5 phases of a proper basketball shot, because this will show you how advanced the G1 actually is. Knee bend for power, upward extension for lift, torso rotation for shot alignment, arm extension for aim, wrist flick for accuracy. If even one of these phases happens too early or too late, the shot is ruined. Humans sync these phases automatically using muscle memory. Robots don't have that. They have to calculate every millisecond. And even while calculating all of this, the G1 must stay balanced. When you shoot a basketball, your center of mass shifts in multiple directions. Forward, upward, sideways. Humans adjust instantly. Robots can't feel balance. They measure and react. So the G1 constantly senses every shift in its body and corrects its stance instantly. Watching the robot hold a fadeaway pose without wobbling is honestly surreal. If you had the chance, would you play basketball with a Unitree G1? Or would you be scared it might dunk on you? Because I swear, I might walk off the court if it hits me with a step-back three. Drop your answer in the comments. I'm seriously excited to see what you do. Meanwhile in China, a humanoid robot just set a Guinness World Record by walking for over 3 days straight, covering 106 kilometers, the longest journey ever recorded for a humanoid machine. This wasn't a treadmill test or a lab demo. It was a real trek from Suzhou to Shanghai, through unpredictable streets, crowds, and traffic. And that robot was the Agibot A2. The Agibot A2 walked 106 kilometers from Suzhou to Shanghai. That's 66 miles through actual city streets with traffic, pedestrians, uneven pavement, and everything else that makes urban navigation complicated for anything without a human brain. Most robot demonstrations happen in warehouses or labs where every variable gets controlled. The A2 walked through the same environment you'd experience on a regular commute. Traffic lights that change unpredictably. Crowds moving in random directions. Tile roads, ramps, surface transitions. The kind of chaos that breaks most autonomous systems within minutes. The robot handled all of it for 106 kilometers straight. But the detail that matters most? Agibot claims they've delivered over 1,000 of these robots. This wasn't a custom prototype that a team of engineers babied through every step. According to the company, any A2 unit rolling off their production line could attempt this same journey. That claim suggests a level of manufacturing consistency and reliability that most robotics companies can't back up with receipts. Think about the failure modes that didn't happen. The robot could have misread signals and walked into traffic. It could have lost balance on uneven surfaces. Navigation could have failed. Power management could have collapsed before reaching the next charging point. None of that occurred over a multi-day journey through 2 major cities. And if you think a 106-kilometer walk is intense, wait until you see what Figure's robots endured inside BMW's factory. Figure's robots just finished an 11-month deployment at BMW's South Carolina factory, and honestly, they look like they've been through hell. We're talking scratches everywhere, factory grime coating every surface, dents and scuffs across their entire bodies. And you know what? That's exactly what Figure wanted to show us. This wasn't some polished demo where everything works perfectly under controlled conditions. These robots actually worked. Real shifts, real production, real problems. Over those 11 months, these machines helped build more than 30,000 BMW X3 vehicles and loaded over 90,000 sheet metal parts. Their job sounds straightforward. Grab parts from bins, place them on welding fixtures with millimeter precision. But here's the thing. They did this every single working day for nearly a year. We're talking 10-hour shifts, 5 days a week. Within 6 months of launching Figure 02, they had robots on BMW's floor being tested. By month 10, they were running full shifts on an active assembly line. But here's the crazy part. The robots weren't perfect. The forearm became the main failure point. Why? Because cramming 3 degrees of freedom, cooling systems, and all those cables into a human-sized forearm created serious problems. The constant motion stressed the microcontroller-based circuit board and all that wiring going to the wrist. Thermal issues, dexterity requirements, tight packaging, all of it added up. What makes Figure different is they're brutally honest about these failures. For Figure 03, they completely redesigned the wrist electronics. They eliminated the distribution board and all that problematic dynamic cabling. Now each motor controller talks directly to the main computer. Less complexity, fewer failure points. CEO Brett Adcock called those battle scars proof of real deployment. And he's right. Those beaten-up robots proved humanoid machines can survive actual factory conditions month after month, not just look pretty in promotional videos. And just as Figure exposes its battle scars, a Chinese startup just went head-to-head with Boston Dynamics, and they did it with a backflip. Phybot's new M1 humanoid didn't just land a clean flip, it landed a human-like one. And here's why that matters way more than it sounds. This company was founded in September 2024. Two Tsinghua University roommates, Ren Xiaoyu and Mao Shuhan, went from engineering students to building a backflipping humanoid in barely 12 months. That kind of speed is unheard of in robotics. Now backflips aren't new. Boston Dynamics Atlas has been doing them for years using heavy hydraulics. Unitree's H1 pulled off the world's first standing backflip without hydraulics in March 2024. Engine AI and Unitree have even done front flips and side flips this year. So what's different? Phybot claims the M1's flip looks more natural, almost human in its movement. You can debate that, but you can't deny how fast the bar is rising. Here's the real shocker. The M1 costs under $42,000. Atlas? Over $1 million. We've officially reached the point where you can buy a humanoid robot for less than a mid-range car. And Phybot didn't build this using open-source frameworks or borrowed designs. Everything is developed in-house, a fully vertical approach similar to Tesla's. That's harder, riskier, and more expensive, but it means total control, faster iteration, and no easy reverse engineering for competitors. But let's answer the big question. Why do companies keep showing backflips if no one needs a robot gymnast? Two-word answer: stress test. A robot capable of a backflip has dynamic balance, explosive power, real-time sensing, and precise control. Those same skills translate to real work, carrying loads, navigating homes, assisting the elderly. Phybot's backflip isn't a revolution. It's a confirmation. A new player can now reach world-class capability in 1 year, and at a price regular people can actually imagine paying. The question isn't whether robots can backflip anymore. It's how soon one will be useful enough that you'll want one in your house. Most humanoid robots today are priced like exotic supercars. $200,000, $300,000, sometimes even $500,000 depending on the company. That's why Xpeng's announcement hit the industry like a shockwave. When He Xiaopeng revealed Iron's official launch price of $150,000, Xpeng instantly undercut almost every major robotics company by tens of thousands of dollars. But the real twist came next. He Xiaopeng said that once mass production begins, Iron's price could fall dramatically, down to around $45,000, a number that suddenly makes humanoid robots feel less like futuristic luxury toys and more like something a normal household could realistically consider someday. But here's where the real comparison gets interesting. Elon Musk has repeatedly claimed that Tesla Optimus Gen 3 could eventually reach a long-term price target of under $25,000. That would make Optimus nearly half the cost of Xpeng's mass production Iron. So now we're watching the first true price war in humanoid robotics. Xpeng pushing toward the $40,000 to $50,000 range, Tesla aiming for $25,000, and the rest of the industry still stuck above $150,000. For the first time ever, companies aren't just competing on movement or AI. They're competing on who can build a robot cheap enough to actually enter people's homes. Here's how He Xiaopeng explained the pricing, and this part is actually pretty smart. He said software makes up more than half of Iron's value. Let me break that down for you. In a car, software is maybe 10 to 20% of what you're paying for. The rest is just materials: steel, aluminum, batteries. But with Iron, the intelligence is what you're actually buying. The robot body is just the thing carrying that intelligence around. And since Xpeng already spent billions developing self-driving car technology, they're basically reusing that technology for Iron. They're getting two products out of one investment. That's pretty clever business. He Xiaopeng also said something interesting about how valuable these robots could be. He claimed Iron could be 1 to 2 times more valuable than cars. His logic actually makes sense. A car just moves you from one place to another. That's useful, sure, but iron could help you at work, assist you at home, and handle tasks in public places. It's not just transportation. It's like having an extra helper across your entire life. Iron becomes more than just a tool. It becomes a platform that can do many different things. And that's where the real value is. Xpeng announced they'll have full mass production running by the end of 2026. And this isn't just talk and fancy presentations. Xpeng is already testing real iron robots in their Guangzhou factory right now. Actual robots working next to humans, doing repetitive tasks, learning to pick up and move objects. This is real hardware being tested, not just concept drawings. Xpeng is aiming for what they call Level 3 autonomy for iron. They're borrowing that term from self-driving cars. What does that actually mean? It means iron can move around and do work without someone constantly watching over it. The technology making this possible is Xpeng's own vision language action system. This technology combines vision, understanding language, and physical movement into one system. All three parts work together at the same time to make iron act independently. What's really smart is how iron can get better over time. Just like Xpeng's electric cars get software updates through the internet, iron will get new abilities the same way. Your robot could literally learn new skills overnight while you're sleeping. That changes everything, because iron isn't a finished product that stays the same forever. It's a system that keeps improving. You're buying something that gets better as time goes on. Here's something revealing though. The robot that walked on stage at AI Day was version 7. The version Xpeng will actually sell in late 2026 will be version 8. He Xiaopeng specifically said the hands need to be better. During early tests in factories, the hands only lasted about a month doing the same tasks over and over. But the fact that Xpeng is being honest about these problems while still promising a 2026 launch tells you they believe the main robot design is solid, the foundation is good, they just need to make the hands tougher. When Xpeng first revealed iron at AI Day in Guangzhou, the entire robotics world froze. Iron didn't walk like a robot at all. It walked like a person. The hips swayed naturally, the steps flowed smoothly, and even the hand movements looked organic. Within minutes, videos went viral across China. People replayed the footage frame by frame, zooming into joints, analyzing every shift of weight. And a massive question exploded online. Was this even real? Some thought Xpeng had put a human inside a costume. Others said the movements looked too biological, pointing at the posture, the spine rotation, the fluid balance. Tech influencers and engineers openly questioned whether iron was an actual humanoid or just a marketing stunt. Then it escalated even more when two identical iron robots walked on stage in perfect synchronization. It looked less like robotics and more like a choreographed dance, fueling conspiracy theories even further. Then Xpeng made a move no robotics company had ever dared. They brought iron on stage again, this time with engineers holding tools, and started taking the robot apart live in front of journalists. No edits, no cuts. They removed sections of the leg armor, exposing the steel frame, motors, cooling systems, wiring, and sensors. The audience could hear the fans spinning and see joints moving in real time. It was like a live robot autopsy. And it worked. Overnight, every conspiracy theory vanished. Xpeng then released footage of iron walking with the outer shell removed, revealing its 3D printed bionic muscle layer, the system responsible for that eerily natural gait. Iron's abilities are just as wild as the reveal. Its 5-part spine lets it bend and twist like a real human, and the bionic muscle layer absorbs shocks for smooth, natural motion. Each hand has 22 degrees of freedom, enough to grip tools and handle objects, though Xpeng admitted the early versions wore out quickly. Stronger versions are already in development. AI just crossed a line we weren't supposed to reach this fast. A small startup from China showed something that felt impossible. A robot moving through a home with the fluidity of real human behavior. No puppeteers, no tricks. And Google are secretly building the AI brain that could run on every robot on the planet. Let's start with MindOn, because what they've shown recently is turning heads everywhere. This 6-month-old Chinese startup out of Shenzhen just showcased a humanoid robot doing household chores with the fluidity that feels eerily human. We're talking about a robot vacuuming on its knees, standing up to open curtains with a gentle tug, climbing onto a stool to water plants on high shelves, carrying packages balanced on one arm, wiping kitchen counters in circular motions, picking up toys from under tables, handing over fruit baskets. The movements aren't jerky or robotic. They're smooth, purposeful, careful. And here's the crazy part. They explicitly claim the robot isn't teleoperated and nothing is sped up. No hidden puppeteer, no fast-forward tricks, no behind-the-scenes control system, just autonomous AI doing real tasks in real time. If this is legit, we're watching a massive leap in what's called loco manipulation, where robots move and manipulate objects simultaneously in unstructured environments like your actual messy home. Now here's where it gets interesting. The hardware. Instead of following the traditional approach taken by companies like Tesla or Figure, building the entire robot body and software stack from scratch, MindOn chose a different path. MindOn didn't build their own robot from scratch. They took the Unitree G1, a popular Chinese humanoid platform that costs around $16,000. Compare that to $100,000 competitors, and you see why developers love it. The G1 has quietly become one of the most attractive platforms for AI researchers. Affordable, rugged, packed with sensors, and flexible enough for everything from locomotion research to manipulation benchmarks. It's basically the developer favorite for experimenting with cutting-edge robot intelligence. The G1 stands about 4 feet 3, has 23 to 43 joints depending on configuration, and comes packed with 3D LiDAR, depth cameras, and force sensors. Out of the box, it's basically a blank slate. Great for kung fu demos, but needs serious software to handle real tasks. MindOn modified it with custom grippers for those dexterous hands and plugged in their proprietary AI brain. Suddenly, this affordable platform becomes a chore master, handling tasks across diverse scenarios with claimed 80% success in unfamiliar environments. That's the industry benchmark for embodied AI that can actually generalize. But the real magic is the tech under the hood. MindOn's whole goal is to build the AI brain, the intelligence layer that can run on any compatible robot body. Quick question for you. Do you think MindOn's robot is truly autonomous, or is there something we're not seeing? Comment real or fake. I'm curious what you think. MindOn's approach combines 3 powerful techniques. First, reinforcement learning, where the robot essentially practices tasks millions of times in simulation, learning from trial and error like a human learning through repetition. Every failure teaches it something, gradually optimizing its behavior. Second, imitation learning, where the AI studies human demonstrations and learns to copy those motions, building a library of useful behaviors from watching how people naturally move and manipulate objects. Third, and this is crucial, sim-to-real transfer, the bridge between virtual training and physical deployment. You can't just train in simulation and expect it to work perfectly in reality because the real world has friction, lighting variations, unexpected obstacles, and a million tiny details that simulations miss. MindOn fine-tunes their models to handle that gap, adapting virtual learning to messy reality. The result is what we see in the demo. Whole-body task fluidity that's genuinely rare in robotics. The G1 bends under tables without losing balance, climbs onto stools without tipping, interacts with moving children without collision. All while maintaining smooth, coordinated motion. MindOn's AI is specifically optimized for contact-rich tasks like pushing, wiping, and manipulating, solving what researchers call the data bottleneck by generating massive training datasets in simulation. Here's the crazy part, though. MindOn is only 6 months old. They're not swimming in billions of venture capital like some competitors. Their mission is laser-focused. Create an AI brain, not another expensive hardware platform. Think of them as the Android of humanoid robotics, providing the smarts that run on existing bodies. Rather than building everything from scratch, they spun out of Tencent's ecosystem, part of China's booming humanoid scene where hardware is cheap and plentiful. Their approach is modular. Sell or license the brain as a service. Imagine upgrading your basic robot with MindOn AI via an app update. That's the vision. If they nail generalization at scale, affordable platforms like the G1 become genuinely viable for homes, undercutting pricier integrated bots from Western giants. This software over hardware model could genuinely democratize robotics, making advanced capabilities accessible without the $100,000 price tag. Make sure to subscribe because every week the AI world drops something insane, and we break it down first. And MindOn isn't alone in this race to build the universal robot brain. Enter Skilled AI, the Pittsburgh startup that's making everyone's jaw drop with their so-called immortal robot controller founded by Carnegie Mellon professors. They've raised $300 million at a $1.5 billion valuation. Their skilled brain is genuinely omni-bodied, one AI model that controls radically different robot bodies. They've demonstrated a quadruped robot getting its legs literally chainsawed off, and it immediately reorganizes its gait and keeps hobbling forward. They lifted a four-legged bot onto its hind legs, and the AI just treated it like a humanoid and walked it around. Motors disabled, wheels jammed, legs tied together, limbs lengthened. The controller adapts on the fly, zero shot, no code changes mid-demo. This is online adaptation in its purest form. The same pre-trained policy changes behavior in real time when the body or environment shifts, without pausing for fine-tuning. Real talk. If a robot can lose a leg mid-task and still keep going, does that scare you or impress you? Comment scared or impressed. How is this possible? Skilled trained their AI across roughly 100,000 simulated robot bodies, exposing it to countless shapes, joint layouts, and failure scenarios. Their transformer model, Locoformer, remembers long histories of sensor data and actions. So when something changes, like losing a leg or gaining height, it infers the new dynamics and adjusts instantly. Instead of memorizing movements for one robot, it learns the general principles of balance and motion, letting it adapt to almost anything with no extra training. But wait, there's more. Google DeepMind just entered the arena with serious firepower. Google is pushing hard toward the same idea, building the AI brain first, and their newest reveal, Phybot A2, is another major step in that direction. Google recently introduced Gemini Robotics 1.5, AI models that let robots reason step by step, plan tasks, use digital tools, and generalize across different robot bodies. The demos show robots sorting fruits by color, separating clothes, following city recycling rules, and even checking whether to pack bags. Two models handle this. Gemini Robotics ER, the planner that understands scenes and creates step-by-step actions, and Gemini Robotics, which converts those plans into precise movements. The key breakthrough is that these robots now think before acting, generating natural language reasoning so their decisions are understandable and far more capable. Google's Phybot A2 is DeepMind's next step toward real-world robotics. An AI trained in open-world games to follow natural instructions, even vague ones, and achieve about 60% success on unseen tasks. It learns from gameplay across multiple titles using a self-improving loop, letting skills like mining or navigation transfer between worlds. Games act as infinite training grounds for embodied AI, and with tools like Genie, DeepMind can generate endless environments. These virtual skills can move to real robots through sim-to-real methods. The goal is clear: robots that follow instructions, explain their reasoning, and adapt in real homes. This is the race we're in right now. Three parallel approaches converging on the same goal: a universal AI brain for robotics. MindOn attacking from the affordable hardware plus smart software angle, skilled building indestructible, morphology-agnostic controllers through massive simulation diversity. Google leveraging their AI empire to create reasoning robots that can plan, search, and explain themselves. The winner could reshape everything: trillions in value, robots in every home and workplace, fundamental changes to how we live and work. We're talking about the ChatGPT moment for embodied AI, where robots finally learn and adapt like large language models do. China's edge in mass-produced cheap hardware combined with AI talent could accelerate this faster than anyone expected. But the US still leads in sophisticated AI architectures and reasoning systems. This isn't just about cool demos anymore. This is about who builds the Android operating system for the physical world. And based on what we're seeing in late 2025, that future is arriving way faster than anyone predicted. Unitree just unveiled a new robot and it's called G1D, and here's the twist. They put wheels on it. I know what you're thinking. Wheels? On a humanoid? But hear me out because this is actually genius. Walking robots are cool in theory, but they break down constantly. They're expensive to maintain, and the balance systems are ridiculously complex. Unitree looked at that problem and said, forget it. Let's solve the hard stuff later and build something that works right now. The G1D still has all the benefits of being humanoid. It's tall enough to reach shelves, it can work at human height stations, and it's got arms with 7 degrees of freedom each. That means the arms move like yours do, with shoulder, elbow, and wrist motion. It can lift about 6.5 pounds per arm. Not massive, but plenty for warehouse picking. The flagship version moves at 5 feet per second, which is genuinely quick for a working robot. Here's where it gets interesting. You can swap out different hands. 2-finger grippers for simple tasks, 3-finger hands for complex objects, or even a full 5-finger hand. It's got HD cameras in its head for binocular vision, plus wrist cameras so it literally sees what it's grabbing. Battery lasts 6 hours, basically a full shift. But here's the crazy part. Unitree isn't just selling hardware. They're giving you an entire AI platform. The robot collects data while working, that data trains better AI models, and those models get loaded back onto the robot. So it gets smarter just by doing its job. You're running a warehouse and developing AI at the same time. That's the real innovation here. And Unitree isn't the only one pushing new engineering philosophies this week. Germany just entered the chat with something surprisingly serious. Germany just dropped a serious new contender into the humanoid robotics race. Munich-based Agile Robots has officially unveiled their first full humanoid robot, Agile One. And unlike the flashy parkour bots we usually see online, this one is built for industrial work, period. Agile One stands about 5 feet 8 inches tall, weighs roughly 152 pounds, and can move at speeds up to 4.5 miles per hour. That's basically a human-sized coworker who can zip around a factory floor without slowing the workflow. But the real magic isn't the size or speed. It's the engineering philosophy behind it. Agile Robots comes from deep German aerospace roots, and their expertise has always been ultra-precise, force-controlled robot arms. With Agile One, they've taken that same mastery and applied it to a full humanoid body. The highlight? Its 5-finger tactile robotic hands. These hands can pick up tiny screws without dropping them, use power tools with controlled torque, tap touchscreens, turn knobs, and handle delicate components without breaking anything. The demo shows refined manipulation, confident walking, and smooth tool use inside a clean, factory-style environment. No circus tricks, just solid industrial capability. Agile One uses what the company calls physical AI, a layered control system trained on real European factory data. One layer handles long-term planning, another handles split-second reactions, and the low-level controls deliver precise force sensitivity. The result is a robot made for variable, messy, real-world manufacturing, not stiff, pre-programmed motions. It's also designed to work closely with people. The expressive LED eyes track human movement. The chest display gives quick status updates, and workers can guide the robot using simple gestures or voice commands. It's friendly, but purpose-built. Production starts in early 2026, and Agile Robots is going straight after the trillion-dollar manufacturing market. If Agile One performs in real factories the way it does in the demo, Europe just gained a serious industrial humanoid rival to the US and Asia. We're talking about Idle, Russia's first AI-powered humanoid robot, making its grand debut in Moscow on November 10, 2025. What was supposed to be a triumphant moment turned into pure internet comedy gold. The robot stumbled forward with the awkward wobble of a drunken man nursing arthritis. Let me back up and tell you what Idle was supposed to be, because this isn't some clunky science project. Developed by Agile Robotics, a Moscow-based startup, Idle represents Russia's push for tech self-reliance amid sanctions that have squeezed their access to foreign components. We're talking 77% domestically sourced parts, with plans to bump that up to 93% in future versions. The robot stands about 5'4", with over 40 degrees of freedom for fluid movement, meaning it's designed to walk, manipulate objects, and even learn in real time from its environment. What really made people turn heads, though, was the design. Idle doesn't hide behind a plastic shell or blank visor. It has a fully human-like face, capable of subtle expressions, mounted on a mechanical yet proportionate humanoid body. A rare combination in robotics today, where most companies focus on either lifelike heads or functional bodies, but not both. Seeing both merged together felt almost unsettlingly real. On paper, it's impressive. The emotional AI is wild too, 12 full facial expressions ranging from joy to surprise to stoicism, plus hundreds of microfacial tics that push right into that uncanny valley charm we all love to hate. So on paper, Idol should have walked onto that stage, waved, maybe done a little dance, and walked off to thunderous applause. Sounds amazing, right? The actual demo was rough, really rough. Idol took a few steps forward, managed one small wave, and then the legs gave out. The whole robot tipped forward and slammed into the stage floor, arms flailing, pieces scattering. It looked like a toddler learning to walk, except made of metal and wires. Be honest. If you were in that audience watching the robot fall, would you laugh or feel bad? Drop your reaction below. CEO Vitukin blamed bad lighting for messing with the sensors. He explained that the robot was still learning how to handle real stages versus controlled lab floors. Fair enough. Even the best robot companies struggle with that. Getting robots to perform perfectly in labs is way easier than dealing with real-world chaos. Some attendees said Idol actually worked fine later backstage after adjustments, but nobody saw that. Everyone saw the fall. The internet, of course, had zero chill memes flooded in within hours. Idol learns to walk from drunk people, Rocky 7, robot knockout, and plenty worse. Some even saw it as a symbolic embarrassment for Russia's tech ambitions. But the truth is, robotics is brutally hard, and that sim-to-real gap is where even the giants stumble. You can train a robot in perfect virtual environments all day, but the second it meets unpredictable physics, bad lighting, uneven floors, and live pressure, everything goes sideways. Vitukin's take was surprisingly grounded. He blamed calibration glitches caused by lighting and said, "It's still learning in real time." And honestly, that's fair. This is the raw, unpolished side of innovation that most companies hide behind closed doors. Russia just happened to show it live. To his credit, Vitukin framed it beautifully. This is real-time learning, when a good mistake turns into knowledge and a bad mistake turns into experience. They even brought Idol back for a short encore after engineers tweaked the code, and it managed to stand and wave. No faceplant this time. Some sources said it later grabbed props and interacted smoothly off stage, proving the tech works when conditions are right. The problem? Live demos are chaos, and Idol just wasn't ready for prime time. Before we keep rolling, hit that subscribe button. We cover everything from mind-blowing breakthroughs to robot bloopers like this one. All right, back to the video. Now zoom out, because while Russia's robot took a tumble, China's absolutely crushing the humanoid game right now. Ubtech's Walker S2 robots are literally rolling off assembly lines in what looks straight out of iRobot. Rows of 5'9" bipedal machines lined up in formation, ready for deployment to factories and data centers. This isn't prototype territory anymore. We're talking mass commercial rollout hitting mid-November 2025. Ubtech dropped a video showing this robot army, and it's equal parts impressive and terrifying. The Walker S2 units feature autonomous battery swapping, docking, pulling out a dead battery, sliding in a fresh one, and getting back to work without human help. That's 24/7 uptime. Specs? Unreal. Whole body dynamic balancing that lets them tilt up to 170 degrees while hauling 33-pound payloads. A human-like gait for moving through crowded factory floors. Fine motor grippers for delicate assembly. Over 40 joints for lifelike motion. Powered by AI chips that make on-the-fly decisions and learn by doing, not just by simulation. And the numbers are staggering. Over 800 million yuan in orders this year, roughly $110 million. shattering every forecast for humanoid adoption. AI robots are going crazy right now. Every week, something appears that looks like it came straight out of a sci-fi fever dream. There are robots doing kung fu, robots running full marathons. But while everyone chases flashy robot stunts, something far more real just dropped. Sunday Robotics just unveiled their new home robot named Memo. Memo isn't trying to break world records or jump over obstacles. It's designed for the place where real life actually happens. The home. Memo walks up to a fully messy dinner table and clears the entire thing. Not just plates and forks. It handles delicate wine glasses, picks up bowls, balances objects, separates food waste, loads everything into a dishwasher, and even starts the cycle. And it doesn't do it with jerky robotic motions. This thing moves with careful, thoughtful precision, almost human-like in the way it senses weight and adjusts its grip. Then, as if that wasn't enough, it turns around and folds socks from a chaotic pile like it's the most normal thing in the world. It pairs socks, stretches them, rolls them into perfect little balls, and drops them in a basket. And yeah, I know there are humanoid robots that can lift weights or climb stairs or do a backflip. But socks, soft fabric, random clutter, that's a whole different difficulty level. But here's the crazy part. Memo also pulls a real espresso shot. Not from a robot-friendly machine, from a standard consumer espresso maker. It actually locks the portafilter into place, something that takes real torque, runs the shot, and serves it. That's when I realized this startup isn't playing around. They're going after real chores, the stuff normal people deal with every day. And they're doing it with a kind of confidence you rarely see in a company this young. Now, usually when we see demos like this, there's a hidden trick. It's either teleoperated, heavily choreographed, or filmed 100 times to get one good take. But Sunday Robotics keeps repeating something bold. Memo is fully autonomous in these demos. No puppeteer behind the scenes. No human secretly driving the arms like a video game character. And if that's true, this is a bigger deal than most people realize. Let me tell you why. Most robotics companies rely on something called teleoperation. A human wears a VR headset or uses special controllers and basically drives the robot. The robot records all of that motion and learns from it. It's powerful, but brutally expensive. You need a big robot sitting in a lab. You need a teleoperator. You need a full rig with sensors and screens. And every time you want more training data, you repeat the whole process. It doesn't scale. You can't put 500 robots in 500 homes just to gather training data. But Sunday Robotics flipped the script. Instead of trying to bring robots into homes to collect data, they asked a smarter question. What if you could bring the data collection to the humans, without the robot ever being there? This is where their skill glove idea blew my mind. They built a special glove that mimics Memo's robotic hand. Same shape, same joint structure, same sensor layout. So when a person wears this glove and does something, whether it's washing dishes, folding laundry, or organizing a messy cabinet, the glove captures every tiny motion, every pinch, every twist, every force signal. And because the glove is designed to match the robot's own hand, the robot can take that data and say, "Oh, this is exactly how I would have done it." Suddenly, Sunday can send hundreds of these gloves to real people in real homes. You want data from a cramped kitchen in Tokyo? A bright Airbnb in Los Angeles? A messy studio apartment in Mumbai? Just ship a glove. Let the person do their daily chores. And now you've got clean, extremely detailed robot-ready data for cheap. They claim it's 100 times more capital efficient than teleoperation. But here's the even crazier twist. When a human uses the glove, the cameras obviously see a human arm, a human wrist, a human body. That's messy data for a robot. So Sunday built a system called Skill Transform that basically rewrites all that footage as if Memo itself performed the action. Same geometry, same reach, same joint angles. It converts human motion into robot motion with something like a 90% success rate. That solves a problem robotics teams have struggled with for years. All of this feeds into their robot foundation model called a CT1. And this is where Sunday takes a huge swing. A CT1 is trained on zero robot teleop data. None. It's all based on thousands of human demonstrations collected from glove wearers across more than 500 homes. That means the model isn't learning how to move like a stiff machine. It's learning from the fluid, intuitive way humans interact with everyday objects. A CT1 controls everything Memo does: navigation, arm movements, finger-level precision, long horizon planning. It decides when to walk across a room and when to slow down and carefully slide a glass between two dishwasher prongs. In one full run, Memo walked 130 feet, handled 21 different objects, and performed 68 total interactions. That is not a scripted sequence. That's Act 1 planning in real time. If Memo is dropped into a brand new home, it builds a 3D map, figures out what objects are where, and tries to solve the task with no pre-recorded routine. That's the part that keeps sticking in my head. This is not the typical lab environment. This is real, chaotic, unpredictable life. And now Sunday says they plan to put Memo into 50 real households by late 2026. That's bolder than most big robotics companies. They want real people testing this robot, giving feedback, shaping what skills it learns next. Yes, Memo is still slow. Yes, it will definitely fail at times. And no, they haven't announced the price yet. But the vision is unmistakable. A robot trained on the collective hands of thousands of people. You teach it by doing your own chores. The robot learns your style, your preferences, your rhythm. That's such a human-first way of thinking about robotics. And honestly, I find it brilliant. Up until now, most teleoperation demos you've seen have either been slowed down or sped up in post-production to hide latency issues. Unitree is showing you the real thing, unedited, and it's genuinely impressive. So let's break down what just happened and why this matters way more than people realize. Alright, so what exactly is this embodied avatar platform? It's Unitree's new full-body teleoperation system that lets a human operator remotely control their G1 humanoid robot with real-time precision at human speed. And I need you to understand what that actually means, because this is where most companies fail. A person wearing a lightweight motion capture suit moves naturally, at their normal pace, and the G1 mirrors every single motion instantly with no delay. Arms, legs, torso, head, all synchronized perfectly. The operator shifts their weight, the robot shifts. They kick at normal speed, the robot kicks at normal speed. They reach and grab quickly, the robot reaches and grabs quickly. This isn't slow-motion puppeteering where the human has to move carefully and wait for the robot to catch up. This is natural human movement being replicated in real time. Here's why that's a massive deal. The biggest problem with teleoperation systems has always been latency. The delay between when you move and when the robot moves. Even a half-second delay makes everything feel wrong and clunky. You can't do dynamic tasks. You can't react to changes. You're basically stuck doing slow, careful movements because anything faster becomes unpredictable. Most companies solve this in demos by either slowing down the operator or speeding up the video in editing. You think you're watching real-time control, but you're actually watching a carefully edited performance. Unitree is explicitly calling out in their demo that there's no speed up in the video. What you're seeing is what's actually happening. Human speed movements, human speed responses, real-time coordination. That's the breakthrough here, and the video makes this crystal clear when you watch the athletic sequences. The operator plays soccer and the G1 juggles the ball and executes kicks with timing that matches human reflexes. Two G1 robots spar in a boxing match, and you can see the footwork and combinations happening at fighting speed, not slow-motion choreography. There's martial arts staff work where the robot swings through complex patterns at the same pace a human martial artist would move. These aren't slowed-down demonstrations. This is dynamic reactive movement happening as fast as the human operator can execute it. The robot is keeping up with human timing, human reflexes, human coordination in real-world physical activities. That level of responsiveness is what separates usable teleoperation from lab experiments. But Unitree isn't just showing off athletic moves for YouTube views. The demo includes real household tasks, and this is where the human speed control becomes critical. The G1 picks up a soda can and uses its leg to pop open a trash bin lid before tossing the can inside. All of that happens at normal speed, the way you would actually do it. Cleaning dining tables, doing dishes at the sink, stacking items in a refrigerator, running a vacuum cleaner. These tasks require coordination and timing. If there's lag in the system, everything becomes frustrating and inefficient. But with human speed teleoperation, the operator can work naturally without constantly adjusting for delay. There's even a scene where the robot brings water and fruit to someone, and the movements are smooth and confident, not hesitant or robotic. If you had full control of a humanoid like the G1, what's the first task you'd try? Drop it in the comments, I'm checking them all. Now here's what makes this genuinely special beyond just the speed. Unitree built this as what they call a full-body data acquisition platform, and that's the real story everyone's missing. Every single time someone operates this robot at human speed doing real tasks, the system is recording everything. Every movement, every timing, every coordination pattern gets captured as high-quality training data. So while you're puppeteering the robot to do household chores or athletic moves, you're simultaneously creating the dataset that will teach robots how to do those things autonomously later. And because it's happening at human speed, the data reflects actual human performance, not slowed-down artificial movements. That's gold for training AI models. Think about that loop for a second. Today, a human operator controls the G1 at natural speed to clean a table or load a dishwasher. That session gets recorded with all the timing and coordination intact. Tomorrow, an AI model trains on that data and learns not just what movements to make, but when to make them and how fast. Speed and timing are critical components of skilled task execution. If you train on slowed-down data, your autonomous robot will move like it's underwater. If you train on human speed teleoperation data, your robot learns to work at human pace. That's the difference between a robot that technically works and a robot that's actually useful. The demo also shows the lightweight motion capture suit the operator wears. Just straps and bands, no bulky exoskeleton, no room full of expensive cameras. You can see it clearly in the footage. Simple harnesses that let the operator move naturally without restriction. And that's important because if the suit is heavy or restrictive, the operator can't move at human speed anyway. Everything becomes slower and more deliberate. Unitree has made the capture system as minimal as possible so the human can move freely and naturally. That freedom translates directly to better robot performance and better training data. Combine that with the G1's price point starting around $16,000, and you're looking at technology that actually scales. Why is this important? Because speed determines usefulness. A robot that can clean a table but takes 3 times longer than a human is basically useless for commercial applications. Nobody's going to pay for that. But a robot controlled in real time at human speed can actually do productive work right now. It can generate value immediately because it's working at the pace that businesses and households actually need. And while it's generating that immediate value, it's also collecting the training data that will eventually make it autonomous. That's a business model that actually works. You're not waiting years for AI to catch up. You're deploying useful robots today that fund their own development toward autonomy. Would you trust a humanoid robot moving at human speed to handle tasks in your home or workplace? Or is that still too risky for now? Tell me in the comments. What makes this announcement feel different is the honesty. Unitree is explicitly stating no speed up in the video. They're not hiding behind editing tricks or carefully controlled demonstrations. They're showing you what the technology can actually do in real time. And what it can do is match human speed across a wide range of tasks from household chores to athletic movements. That transparency builds credibility. It shows confidence in the technology. And it sets a new standard for what teleoperation should mean. Not slow, careful remote control, but natural human speed projection into a robot body anywhere in the world. AI robots are coming faster than anyone expected. And what you see in polished demos is only the surface. Behind the hype, there are hidden dangers, silent failures, and truths most companies don't want you to know. Number 1, companies only show you the safe demo version. How a robot performs on stage doesn't tell you how it behaves in the real world. Those slick demos where everything looks perfect, most of them are carefully controlled theater. Tesla showed Optimus serving drinks and moving like it was fully autonomous, but a lot of that behavior was actually controlled by humans behind the scenes. And while some companies still rely on that polished illusion, others are finally showing the messy, imperfect side of humanoid robotics. Boston Dynamics does the opposite. They show Atlas slipping, missing jumps, even falling off stages. And those failures aren't rare. Real-world deployments prove it. In China, a Unitree H1 working inside a factory misread a safety tether and started violently flailing its arms, almost hitting workers before people stepped in. Marketing shows you the 5% that works. The other 95%, the bugs and edge cases, is where the real safety story lives. Number 2, safety failures in AI models will become safety failures in bodies. Today, AI messes up in your feed. Tomorrow, those same brains will power robots that can move, lift, and grab. Right now, the failures are in chatbots like ChatGPT, Gemini, and Grok. That already hurts people. From chatbots mishandling users' questions to assistants giving dangerous medical advice with full confidence. Now imagine the same kind of model controlling a home robot that hands you pills, a care robot lifting elderly people, or a warehouse robot deciding how fast to move around workers. A weird answer can turn into the wrong object, a risky movement, or a collision. If we don't fix AI safety while it's still in software, we risk putting those failures into bodies made of metal. Would you trust a robot to handle something dangerous or delicate around you? Let us know in the comments. Number 3. Built-in discrimination will be baked into robot decisions. AI bias doesn't stay on a server. It walks around with robots in the real world. Facial recognition already makes far more mistakes on darker-skinned people, and several innocent people have been wrongly arrested because systems picked the wrong face. Now put that tech into robot cops, security robots, or border robots that decide who to follow, who to flag, and who to block. The same thing is happening in hiring. Many companies already use AI to filter job applications, and people tend to trust whatever the system recommends. Turn that into a humanoid interviewer or HR robot, and you've basically given biased code a friendly face and a confident voice. Robots don't magically fix bias. If the brain is biased, the robot calmly enforces that bias at scale. Number 4. Your future home robot may be a walking surveillance camera. To make robots truly useful, companies want them inside your home, and that has massive privacy trade-offs. Some home humanoids and telepresence robots already rely on human operators who can see through the cameras and remote control the machine when the AI gets confused. At the same time, they collect training data from real homes to improve the model. So you're not just buying a helper. You're potentially paying for a camera on legs that strangers can occasionally drive around your living room. Now imagine cleaning robots, elder care bots, or kid-friendly companions using the same setup. The help is real, but so are the questions. Who owns the footage? Who can access maps of your house? What happens if that data leaks or gets sold? Number 5. Emotional manipulation will get supercharged once robots have bodies. AI already forms emotional bonds through chat. Adding a body, a face, and physical presence takes that to another level. People are already treating ChatGPT-style tools like partners, friends, and therapists. Heavy daily use has been linked to more loneliness and less real-world socializing. Now give that same AI a humanoid body that mirrors your expressions, speaks in a warm voice, and sits next to you every evening. That's powerful for therapy, coaching, or companionship, but also perfect for addiction, dependency, and subtle influence. A robot that knows exactly what keeps you engaged can slowly nudge your mood, habits, and beliefs over time. If you want more deep, honest breakdowns of the real robotics world, not just the hype, make sure to subscribe. We uncover what others don't. Number 6. Robots can now learn tasks just by watching human videos. We're moving from program every step to show, don't tell. New robot learning systems let machines watch a few human videos and then practice for a short time before doing the task themselves. In lab tests, robots trained this way massively improved their success rates compared to old methods. Robots have already learned to flip food in a pan, hammer nails, manipulate tools, and imitate surgical steps just by watching humans. Any worker could show a robot how to pack boxes, restock shelves, or help with rehab. No code required. The dark side: the same pipeline can copy dangerous behavior if someone feeds it the wrong demonstrations. Once robots can learn like this, they spread into new jobs much faster than old industrial machines ever did. Number 7. Factories are quietly replacing human workers with robots. The robot job revolution isn't someday. It's happening quietly, right now. Some factories that used to employ hundreds of people now run mostly with robot arms and a small human crew. Big manufacturers have already replaced tens of thousands of workers with robots across multiple plants. Now add the next generation of humanoids. Companies are building robots that can move in human spaces and swap their own batteries, so they can work almost 24/7 without breaks. Yes, robotics also creates new roles. Robot technicians, AI trainers, safety supervisors. But nobody is honest with workers about how fast routine physical jobs are being automated in the background. Number 8. Military robot tech is years ahead of public demos. The most advanced robots aren't in product launch videos. They're in military tests. You've already seen clips of robot dogs with rifles or quadrupeds being dropped onto rooftops by drones. Those aren't sci-fi film shots. They're real training exercises. Militaries are experimenting with robot scouts, armed ground units, and swarms that coordinate with drones. Target tracking and navigation get better every year, and military research is usually several years ahead of what we see on YouTube. The rules we set now, or fail to set, will trickle down into police robots, border robots, and private security bots later. Are military robots the future of defense, or the start of something dangerous? Let us know in the comments. Number 9. Governments are quietly building robot-driven economies. While most people are just asking, will a robot take my job? Governments are already betting their economies on the answer. Countries like China, South Korea, Japan, and several EU members are pouring billions into robotics funds, factory automation, healthcare robots, and robot-friendly infrastructure. They're planning for aging populations, labor shortages, and global competition by assuming robots will fill the gaps. The next global superpower won't just be about software. It'll be about who controls robot supply chains, robot factories, and robot standards. Number 10. Robots are starting to outperform humans in precision work. In the most delicate tasks on Earth, robots aren't just catching up. They're starting to win. Surgical robots already help doctors operate with tiny incisions and extreme precision. With AI that can learn from real surgical videos, robots now execute parts of procedures with skill close to experienced surgeons, and sometimes recover smoothly from small mistakes, like dropping a needle and picking it back up. Scale that idea to microassembly, lab work, and maintenance in dangerous environments, and you see the pattern. Wherever precision, repetition, and stability matter, robots are on track to be better, cheaper, and more consistent than humans. That doesn't make humans useless. It shifts our role toward designing workflows, handling edge cases, and dealing with ethics, responsibility, and empathy, the things robots still can't fake.